Hey, what's up, guys? Today, let's look at the Lintcode 109 triangle. You were given a triangle and you need to find a minimum path sum from the top to bottom. So each step you may move to adjacent number on the row below. So this is the example. You have this triangle and the minimum path from top to bottom actually is this one, 2, 3, 5, 1. You need to know that the basic rules is that you can only just move to adjacent numbers. So you cannot do the passes like this 2, 3, and 7 because 3 and 7 they're not adjacent. So this is our background. You basically, from top to bottom, we have just so many passes, and we need to figure out the minimum one. So how do we do this? Actually, you can use brute force to do this. It's quite simple. But today, we're going to just use dynamic programming to do this. Again, why is dynamic programming? Because we have some keywords here. We have minimum. Like I mentioned before, dynamic programming is good at resolving the questions, the issues like minimum, maximum, feasible, or not, or if you just see the keywords, you got to think of the dynamic programming. All right, so let's see how to do it. Still, we have to answer four questions before we proceed to coding. So first thing is the definition. If we want to use dynamic programming, we need to give a definition to DPIJ because in our case, we obviously it's a two-dimensional solution space, so we have to initialize the two-dimensional DP array, and we need to give a definition to DPIJ. What does it mean? DPIJ, this is how we define it. DPIJ stands for the minimum path sum from the top to point ij. All right, so our answer is that we need to find a minimum path from top to bottom, but we don't know which data point at the bottom is the final point. So our answer should be like this. We do a max DP last row. I mean this row. This is DP last row. I mean this is DP this point, DP this point, DP this point. So each data point of the last row it got a DP value, and then we need to just get the maximum from that. This is quite different, right? And previously we can just directly give the answer, by return one of the DP states, but this is different. We need to do extra operations on the DP states, which is the max. Actually, it's quite normal. When you just do more questions, you get used to this. Our third one is a state transfer. We need to know that what is the relationships between the DPIJ and DP its adjacent states. Okay, so take one for example. Take 5 for example. This we assume 5 is the DPIJ, is the IJ. So if we want to reach 5, we can just only from 3 or from 4, right? If you just think this is like a like a row and this is column, so it is like a like a triangle grade, but it's just like a half grade. So if you map them to the coordinates, and you realize that DPIJ actually is the minimum of DPI minus 1, J minus 1. This is I minus 1, J minus 1, and I minus 1, J. This is I minus 1, J. You can just draw the coordinates on a paper. So 2 actually coordinates is 0, 0, and 3's coordinates is 1, 0, and 4's coordinate is 1, 1, and same thing. And 7's coordinates is 3, 3, and 3's coordinates is 4, 4. Yeah. So If you just give them all the coordinates, then you will have this state transfer equation. So we just choose the minimal path sum from our source, and we just add our data point on that target position. Alright, so this is the state transfer equation, how we solved our biggest problem. So the next one will be initialization. If it is two-dimensionally, like I mentioned before, we need to initialize the column 0 and the row 0, but in this case, it is a triangle. But it's fine, triangle. We're also going to just initialize its outline, initialize its edge. We're going to initialize this. This is quite like a column 0, right? Also initialize this. This line, this edge is like a row 0. Yeah. All right. So this is done. So let's just look at the code. First, we're gonna just try to check the parameters. If triangle is now, we just return -1. And here we get the dimension, and we initialize the DP space, and we give the initialization value. Obviously, DP00 is triangle 00, right? And this part is for initialization, and for row column 0, and this is our equation. Because for row column 0, we can only just come from row -1 column 0, and then we just plus our own data. And DP row which is also very similar. We just can only come from the row -1, row -1. For example, 3 can only come from 7. 3 cannot come from anyone else. Cannot come from 5, because 5 is not its adjacent number. All right, so then we're gonna just use two nested for loops to calculate the whole DP. And in the body of the for loops, we're gonna just apply our state transfer equation here. All right, so once this is done, once the for loop is done, we just return our answer. Our answer is minimum DP m-1. All right, so that's the code. Let's run the code. Come on. Yeah, sometimes Lintcode is just so super slow. All right, so so far so good. Looks like everything is fine, and 100% passed all the test cases. All right, thanks. That's today's algorithm. Thanks. I see you next tutorial. Bye bye.